In this video we are going to go through some of the maths related to gas rate and heat inputs. This is based on the Irish plumbing apprenticeship T2 exam of phase 4. So a question that could come up on your T2 exam could be something like this. Calculate the gas rate of an appliance that has a meter reading of 48.118 meters cubed, and after 2 minutes the meter reading was 49.101 meters cubed. So what we could do there is find the gas rate for 2 minutes. 2 minutes, it was this at the start. After 2 minutes it was this. So if you take one away from the other, you have your 2 minute gas rate. So solution to part 1, gas rate over 2 minutes is going to be the bigger number, which is the second reading, 49.101, take away 48.188, and when you do that, I'm just going to type it into the calculator, 49.101 minus 48.188, we get 0.913, and the unit is the same, that's still meters cubed. So I'm just going to scroll down here and we have the formula for gas rate. The gas rate is the amount of fuel consumed, that just means used, so the amount of fuel used in 1 hour, and the unit is meters cubed per hour. So gas rate, fuel used in 1 hour. So up here we found the fuel used in 2 minutes, but we want the fuel used in an hour. Well, an hour has 60 minutes. We want to know how many 2 minutes is in 60 minutes. So if we divide that by 2, we get 30. So I'm going to have to multiply this by 30, and that's going to give you the gas rate per hour, HR per hour. We're going to get 0.913 multiplied by 30, and that is going to give us 821.7, and the unit is still meters cubed, and you could have said up here that's meter cubed per 2 minutes. So now this is meters cubed per 60 minutes or per hour. So that is the answer to the first part. Now if we look at part 2, calculate the net heat input for this gas, and they're telling you that the gas is natural gas, and sometimes the question just say CV of natural gas is 10.8 kilowatts per meter cubed. CV is short for calorific value. So I'm going to scroll down here again. We're going to look at calorific value. The calorific value is the amount of potential heat energy in a unit volume. So in 1 unit. That's like saying in 1 meter cubed, because volume is some unit cubed. So in 1 meter cubed of gas, and our question says is 10.8 kilowatts. So we don't just have 1 meter cubed, we have 821.7 meters cubed. So that's going to be our first step. So the heat input, this is actually your gross heat input, And I had the heat input formula down here as well. Your heat input is the amount of heat produced in 1 hour. Again, very similar to the gas rate, except for gas used in an hour, it's heat produced in an hour. So gross heat input, well, that is going to be your gas rate from your previous question multiplied by your calorific value. Our gas rate was 8 to 1.7 and our calorific value is in the question 10.8. I could put the units on there as well actually. So this is meters cubed per hour, and then this is kilowatts per meter cubed. Just going to move everything over so we have space for that. Now, kilowatts per meter cubed, and when we do that calculation, multiplied by 10.8, we get a rather large number. We get 8,874.36. And now when you have these units, this is like having your meter cubed on the top of the fraction. This is on the bottom. So when you're multiplying and dividing by the same thing, they cancel out. And you're left with kilowatts on the top per hour. So that is your unit for heat input. Kilowatts per hour. Except we're not done there, unfortunately. And the next part, it's just one last little step, and it's going to depend on the type of fuel you're burning. So you calculate then the net heat input. So you get your net heat input. What you have to do for that is you get your gross heat input, and we either divide by 1.1 for methane or natural gas, or we have to divide by 1.2 for an LPG. And if we just look at our question, it tells us we're burning natural gas. So I'm going to have to do, we can erase that because we're not dealing with LPG, but the next question we will be, so we're going to have to divide by 1.2 in your next question. So here we have 8874.36 kilowatts per hour divided by 1.1, and that's going to give us 8,067.6, and the unit's the same, kilowatts per hour. And that is, just make sure we've answered the question, that's your net heat input. So to get the net heat input, the extra little bit after you get the gross is just that division by 1.1. And that's that question finished. So if you think about your definitions, hopefully there won't be much learning in that kind of question. And now we're just going to look at another example here. So calculate the gas rate of an appliance that has a meter reading of 77.432, and after 2 minutes, so I'm going to start highlighting this so we can eliminate a lot of the words. After 2 minutes, the meter was this much, and this was our first reading. So we can get our 2 minute gas rate. 2-min gas rate, well, it's going to be the difference in your two numbers. If you do the smaller number first, then the bigger number, you're going to get a negative answer. So you know you've put it into the calculator the wrong way. But if you do the bigger number, which is the 82.010, I forgot the unit here. This is meters cubed. This is meters cubed. And this is kilowatts per meters cubed. Okay. So we have that meters cubed subtract 77.432 meters cubed. And when you're putting this into your calculator, you don't put in the unit. You leave out the unit and you just write the unit at the end down here. That is how you do them. And we need a little cube on that, so we don't put in the unit into your calculator, and then we just do 82.01 minus 77.432, and we get the difference there is 4.578 meters cubed. And now, just like the last question, we want the hourly gas rate. So the actual gas rate is going to be that 4.578 multiplied by 30. So that is because you took 2-minute segments and we want to scale it up to be an hour. So that's 137.34. And again, it's meters cubed. Just a side note on that. If the question wasn't 2 minutes, for example, if it was 5 minutes, your 5-minute rate was 4.578. Well, how many 5 minutes is in an hour? You do 60 divided by 5. That goes into 60 12 times. So you're going to have to multiply this by your 12 to get your 60 minutes. So that was just a side note, and it could be any different period of time. If it was 10 minutes, you got your first reading, and then 10 minutes passed, you got your second reading. Well, you're only going to have to multiply by 6 there, because 60 divided by 10 is 6. So you're going to have to multiply by 6. That's why we have to multiply by 30. All the questions I've seen, though, you multiply by 30 because you get a 2-minute reading. And then for question 2, calculate the net heat input for the gas if the gas is propane and the CV of LPG propane is 25.87 kilowatts per meter cubed. CV is short for calorific value. Calorific value is the potential heat energy in 1 unit volume or in 1 meter cubed of gas. So we don't just have 1 meter cubed, we have 137 meters cubed. So heat input is, this is actually your gross heat input. I could add that there. Gross heat input 137.34 meters cubed multiply by 25.87 kilowatts per meters cubed is 3552.9858, and that's kilowatts. So now we're left with kilowatts per hour. I missed the hour part of this unit here, per hour. So that's your gross heat input. Then you only have one thing left to get your net heat input. That is when you divide your gross either by 1.1 or 1.2, and it depends on the fuel you used. So if we look up here again, net heat input for the gas is propane, and the CV is this. So this is an LPG. So for the LPG, we have to divide by 1.2. Kilowatts per hour divided by 1.2, because it's a liquid petroleum gas, 2,960.8215 kilowatts per hour. And hopefully that helps you answer them questions. There's not much learning in it once you understand the formulas. So it would be important to understand them formulas: calorific value, gas rate, and heat input. I've also written here then about your calorific value, that the energy is released by combustion in the form of heat. So when you burn a fuel in oxygen, that's what combustion means, when you burn a fuel in oxygen. And another question on your gas paper could be, what is the products of combustion? And usually they would be talking about, that should be a B. Usually they would be talking about complete combustion. So the products would be carbon dioxide, which is harmless, and water vapour. And you could learn it, the words or the symbols. And then products of incomplete combustion. There is a dangerous chemical released if incomplete combustion happens, and that is carbon monoxide, or CO. And that's the end of this video. Thank you for watching. I hope that helped with your exam preparation.